students, I am Asma and I am here with the 7th program of calculus of BSCS level, which is about functions and different operations on functions. But before going to today's program, let me briefly explain that what we have studied in our last program. We studied distance formula, midpoint formula for 2 points, circles and circle equations, quadratic equations and their solutions. As I told you that today's program will be focusing on functions and operations on functions. Dear student, today we will study functions, notations of functions, arithmetic operations on functions, composition of functions, expressing a function as composition, and classification of functions. First of all, let's come to the function. The term function was used by Leibniz in 1673 to denote the dependence of one quantity on the other quantity. You can see an example of the function on the screen. Here area is equal to pi r square, where r is an independent variable and a is a dependent variable. So we can say that a is a function of r, or area is a function of its radius. In general, if a quantity y depends on a quantity x in such a way that each value of x determines exactly one value of y, then we can say that y is a function of x. You can see some example of functions on the screen. As in first example, we have y is equal to 4x plus 1. Second example is y is equal to 3x minus 4. And the third example is y is equal to x square. In all these examples, x, which is on the right hand side, is independent variable, and y, which is on the left hand side, are all dependent variables. From all these examples, it's clear that y is a function of x because each value assigned to x will definitely determine exactly one value of y. You can see the general notation for function on the screen. The general notation for function is y is equal to f of x, where y is considered as dependent variable and x is independent variable. Now, if you have an equation y is equal to x square, that defines a function f that associates the number x square with the number x. You can see the same example on the screen. A function y is equal to x square, and if we put x is equal to 3 in this function, so we get f of 3 is equal to 3 square, which gives you 9. So it shows that f associates 9 with 3. If we put x is equal to minus 2 in this above function, so f of minus 2 would become minus 2 square, which is equal to 4, and that shows that f associates 4 with minus 2. As in third case, if we put x is equal to under root 2, so f of under root 2 would give you under root 2 square, which is equal to 2. So it shows that f, which is function, associates 2 with under root 2. So it's quite clear that any function f associates the number of that function with the number x. Some notations of functions can be as y is equal to f of x, or y is equal to g of x, y is equal to p of x. In all these examples, all the x's which are on right hand side are considered as independent variable, and all the y variables are considered as dependent variable. Now we will consider two examples of functions, and we will find out the value of function by putting different values of x in the function. You can see an example on the screen. If we have a function f of x is equal to 3x minus 4, now we will find out some values of this function by putting some values of x. For the first case, if we put x is equal to 0, so the value for function would become minus 4. For the second case, if we put x is equal to 1, so the function value would become minus 1. For the third case, if we put x is equal to 2, the function value would become 2. For the fourth case, if we put x is equal to minus 3 in this function, so the function value is minus 13. as in last case, if we put x is equal to under root 2, so the function value is 3 under root 2 minus 4. Now we will consider an example of trigonometric function to understand the concept of function more clearly. But first, going to this example, I will briefly explain that what are the trigonometric functions. You can see the definition of trigonometric functions on the screen. Trigonometric function is a function having trigonometric values like sine, cosine, tangent, secant, cosecant and cotangent. Now we will consider an example having trigonometric function. You can see the example on the screen. If we have an example f of x is equal to sine of x, where sine of x is a trigonometric value. Now we will find out the value for this function by putting different values of x. For the first case, if we put x is equal to 0, so f of 0 would give you sine of 0, which is equal to 0. For the second case, if we put x is equal to pi by 2, so f of pi by 2 would be equal to sine of pi by 2, which is 1. For the third case, if we put x is equal to 1, so f of 1 would give you sine of 1, and finally sine of 1 equal to 0.8414. In the same way, by putting different values of x in the function, we can find out the value of function, or we can find out the value of y, which is dependent variable. Now we will define some operations on function that can be performed. Operations on function. As numbers can be added, subtracted, multiplied or divided to produce some other numbers, so functions can be added, subtracted, multiplied or divided to produce some other functions as well. You can see some arithmetic operations on the screen which can be performed on functions. Arithmetic operations on functions are like addition or sum function, subtraction or difference function, multiplication or product function, and finally division or quotient function. Dear student, now we will see the formulas for sum, difference, product and quotient of the functions. Functions are added, subtracted, multiplied or divided in the natural way as numbers are. You can see the formulas for sum, difference, product and quotient by considering two functions. That is on the screen. If we have two functions, which is f and g, then the formula for sum is f plus g of x is equal to f of x plus g of x. Then the formula for difference is f minus g of x is equal to f of x minus g of x. And the formula for product is f into g of x is equal to f of x into g of x. And finally, the quotient formula can be defined as f over g of x is equal to f of x divided by g of x. Students, now we will consider an example and then we will apply some mathematical operations or mathematical formulas on these functions. You can see an example on the screen. If we have f of x is equal to 1 plus under root x plus 2, and as the second function g of x is equal to x minus 1, and we have to find out f plus g of x, f minus g of x, f into g of x and f over g of x. Now you can see the solution of this example on the screen for sum, difference, product and quotient formulas. We will find out the solution by putting values of f and g in the sum formula, which is on the screen. For the sum of the function, we have f plus g of x is equal to f of x plus g of x. 1 plus under root x plus 2, which is the value for f of x, and x minus 1, which is the value for g of x. So finally, the sum of two functions would become x plus under root x plus 2. In the same way, we will find out the difference of the function by putting the value of f and g in the difference formula, which is on the screen. For the difference of functions, f minus g of x is equal to f of x minus g of x. Now by putting the value of f of x and g of x, we have 1 plus under root x minus 2 minus x minus 1. And finally, we get the difference of two functions as 2 minus x plus under root x minus 2. Now we will find out the product two function in the same way by putting the value of f and g in the product formula, which is on the screen. For the product of function, we have f into g of x is equal to f of x into g of x. Now by putting the value of f and g, we have 1 plus under root x minus 2 into x minus 1. So finally, the product of functions become x minus 1 plus under root x minus 2 into x minus 1. In the fourth part, we have to find out the quotient of the function by using the formula of quotient. You can see the quotient of two functions on the screen. So for the quotient of function, we have f divided by g of x, which is equal to f of x divided by g of x. Now by putting the value of f and g, we have 1 plus under root x plus 2 divided by x minus 1, or by more simplification, if we adopt the form like 1 plus under root x plus 2 divided by x minus 1. Dear students, after defining some basic operations on function, we will now study the composition of functions. We are going to consider an operation on functions which is called composition. Dear students, now let's consider some compositions of two functions. You can see the composition of two functions on the screen. The composition of f with g will be denoted by f of g of x, and the composition of g with f will be denoted as g of f of x. Dear students, now let's consider a mathematical example to explain the composition of two functions. You can see an example on the screen. If we have first function, which is f of x is equal to x square, and the second function g of x is equal to x plus 1, and we have to find out the composition of f of g of x and g of f of x. Now for the solution of finding out f of g of x, we have to substitute the value of g of x for the x in the function of f. That's what on the screen. For f of g of x, first of all, we will put the value of g of x in this formula. So the expression become f into x plus 1. And finally, we will put x plus 1 in the place of x in the function of f of x. So the final expression would become x plus 1 whole square, which is showing the composition of f with g. For the second solution of finding out the value of g of f of x, we have to substitute f of x for x in the function of g. You can see that solution on the screen. First, we will put the value of f of x in this formula. So the expression become g into x square, because f of x is equal to x square. And for the final solution, we have to put x is equal to x square in the function of g of x. So the expression become x square plus 1. Dear students, we can also find out the composition of f with the function f and the composition of g with the function g. You can see both of these compositions on the screen. The composition of f into f would be denoted as f of x, and the composition of g into g would be denoted as g of x. Our next topic is expressing a function as composition. Many problems in mathematics are attached by decomposition of functions into composition of simpler form. You can see the expressing of a function as composition on the screen. The expressing of a function as composition would be denoted as h of x. The composition of two functions would become h of x is equal to f of g of x. Now you can see an example of expressing a function as composition on the screen. So the function which is expressed as the composition will have the final expression as h of x is equal to x plus 1 whole square, where g of x is equal to x plus 1. So the second expression would become h of x is equal to g of x whole square. The second expression is the result of f into g of x. So finally, the expressing a function as composition would become h of x is equal to f of g of x. Over here, the thought process of this example suggests a general procedure for decomposing a function h into f of g of x. That process can be shown on the screen. Here we would evaluate h of x for a specific value for x by trying to break the evaluation into two steps performed in association. The first step in the evaluation will determine a function g, and the second step in evaluation will determine a function f. Dear student, the last and the next topic which we will study is the classification or categories of the function. First of all, we will define a constant function. The simplest of all functions are those that are having the same value to every value of x. These are called constant functions. You can see an example of a constant function on the screen. If we have a function f of x is equal to 3, now by putting x is equal to minus 1, the function would give you 3. By putting x is equal to 0, again the function value is 3. The second classification of function is monomial function. A function of form c x raised to the power n, where c is a constant and n is a non-negative integer, is called monomial function. You can see the definition and example of monomial function on the screen. A function of form c x raised to the power n is called monomial function. Some examples are as 2x raised to the power 3, pi x raised to the power 7, minus 6x, or 4x raised to the power 0. Now we move to the third classification of functions, which is polynomial functions. A function that is expressible as the sum of many monomial in x is called polynomial function. You can see the examples of polynomial functions on the screen. Polynomial function examples are like x cube plus 4x plus 7, where x cube, 4x and 7 are monomial, and the combination of these three monomial become polynomial. You can see the general form of polynomial functions on the screen. The general form of polynomial can be like f of x is equal to a naught x raised to the power 0 plus 1 x raised to the power 1 plus a2 x raised to the power 2 plus up to so on. The last term would be like an x raised to the power n. Over here in the general form of polynomial, n is a positive integer and a naught, a1 up to so on an are considered as constant, and the highest power of x is called degree. As I have told you that the power or the degree of any variable is considered as positive, and wherever this degree or the power of variable would be negative, that would not be considered as a polynomial function. Now we move to the fourth classification of function, which is rational function. Rational function is a function which is expressible as the ratio of two polynomial. You can see the example of a rational function on the screen. Examples of rational functions can be like x square minus 2x plus 1 divided by x square minus 4. Dear student, now we move to the fifth classification of functions, which is algebraic function or explicit algebraic functions. Now the functions that can be evaluated using many additions, subtractions, multiplications and division and root extractions as well are called explicit algebraic functions. You can see two examples of explicit algebraic functions on the screen. As in first function, we have f of x is equal to x raised to the power 2 by 3. So it's quite clear that all the functions which can be separated are called implicit algebraic functions, and all the functions which cannot be separated are called explicit algebraic functions. Now the sixth classification of functions is trigonometric function. The functions which are containing trigonometric values are called trigonometric functions. You can see the example of trigonometric functions on the screen. Trigonometric function can have the form like f of x is equal to tangent of x plus cosecant square x. The seventh and the last classification of functions is exponential function. All the functions which are containing exponential notation are called exponential functions. Here again you can see the example of exponential functions on the screen. F of x is equal to exponential of x plus 9. Dear student, that was all for the classification of functions. Here I am going to summarize today's program. In today's program we studied functions, some notations of functions, some arithmetic operations on functions, composition of functions, expressing a function as composition, and classification of functions. Dear students, I hope that you have enjoyed today's program and understand the function and all the operations performed on functions. We will meet you in the next program with an introduction and understanding of domain and range of functions. Till that time, Allah Hafiz.